Okay, so today we are going to learn how to find if a given number is a perfect square or not. So there are several methods that I'm going to explain, but let's first look at this table because this is very important for this first method. So in the decimal system, there are 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you take the square of these numbers, you see these numbers like 0, 1, 4, 9, 6, 5, 6, 9, 4, and 1. These are the unit place numbers. And other than these numbers like 2, 3, 7, 8 are not at the unit place of any of these digits square. So what we think, let's say I'm giving an example, 82. If I ask you, is 82 a perfect square? So what will you do? Choose, okay, let me start dividing by 2 and then again do the find all the factors and then find whether it's a perfect square or not. So no, we don't have to do that. The first approach, just look at the digit at the unit place. If it's 2, 3, 7 or 8, it's definitely not a perfect square. Okay? But if it has 0, 1, 4, 5, 6 or 9, it can be a perfect square or it cannot be a perfect square. So only if you have one of these digits at the unit place, then you start looking into its factors. If you have one of these digits, 2, 3, 7, 8, don't even think about factorization or applying some other method to identify whether the given number is perfect square or not. It just, you can say, okay, it's not a perfect square because it has 2, 3, 7 or 8 at the unit place. Now look at the second approach. Okay, I give you another number, let's say 72. Again, wrong example, let's take 76. And how to find out if this number is perfect square or not. So this method we can use. So start with finding all the factors. We call it, there are several ways to do, like you can do this way, 2 and 38, 2, 19, or same thing, some people it's called making a tree. So 38 and then 2 and 19. And what you have to do, you have to find the pair. If any number is without its pair, it means the number is not a perfect square. If all the factors have its pair, then the number is a perfect square. So here in this case, we can write 76 equal to 2, its frequency or occurrence is 2, so 2 power 2, and then 19. This 19, this guy does not have a pair. So that means it's not a perfect square. Now let's take another example. Okay, 36. I'm taking each examples. Once we understand how to find out if a number is a perfect square or not, then we will take some bigger numbers. So let's start with the same approach, tree approach. 2 times 18, 2 times 9, and then 3 times 3. Okay, now what you have to do here? You have to use only prime numbers. Okay, don't use non-prime numbers. Always use prime numbers. So 2 is a prime number, 3 is a prime number, and even if you have some bigger number, always try to use the prime number. That's why we call it prime factorization, because you are supposed to use only the prime numbers. Now let's write this guy. 36 equal to 2 has how many occurrences? 2. So 2 power 2 times 3, how many? 2 occurrences. So both of these numbers, 2 and 3, they have their own pair. So it means it's a perfect square. So these are the small numbers, and we can use one of these approach, like if I give you some big number 3, 6, 7, 8, is it a perfect square or not? So since you know if 8 is there at the unit place, it's not perfect square. You can, without doing any factorization, you can say it's not a perfect square. But what if I give you this number, let's say 3676? Oh, this is a big number. So how you are going to find? And now if you think, okay, I will apply prime factorization, let's do that. 2, okay, 2, 9, 2, 1, 1. Now this is big number, and if I try to divide it by 3, 9 plus 9, 18 plus 1, 19, so it cannot be divided by 3, cannot be divided by 4, not 5, not 6, because it cannot be divided by 2 or 3, so you cannot divide it by 6. Or we should not think about even 6, because 6 is not a prime number. What about 7? Can we divide it by 7? No. Then what about 11? 88? No. So you're seeing what's happening here. You keep moving, like increasing the value of the prime number to find the factor that can divide this 919, and it's a really time-taking job, because you don't know, it may be divided by some big prime number like this 39 or 40, 39, not 39, 37. So this is not a good approach when you have a big number. In that case, we have this third approach, which is called range. I call it range method. I don't know what is the term for this one, but I call it range method. Let me explain how we are going to use this guy. 3676 is the example. So here you can see I have taken like 10, 20, 30, 40, all the numbers that ends with, like that has 0 at the unit place. And if you take the square of the square of these numbers, it's easy. And here is up to 10, you can take 110, 120, 130, 140, because it's easy to find the square of those numbers. So for example, this one, 3676. So where does it fall? 3676 between these two numbers. So you can say 3600 is smaller than 3676, smaller than 4900. Okay? And we know the square root of this guy is 60, and we don't know the square root of this guy. So I'll write like this, and then the square root of 4900 is 70. So one thing is sure, that the square root of this number is between 60 and 70. Now, instead of looking long range of numbers, you can find the square root of this number between two digits. So now what you do is check from 61 to 69. Now again, let's go to this table. What digit is at the unit place? 6. So where we have 6 here? So it's 6 or 4. So basically I have to check just two digits. Two numbers, sorry. One is 64, another is 66. So if we just multiply 64 by 64 and 66 by 66, these two, I can, if these two multiplication is not giving this 36, 76, we know that it's not a prime number. If it's giving this number, it's a prime number. So now looking at, so this range method is one of the quickest way to find whether a given number is a perfect square or not. So now let's look at another example, the one we know. Okay, so let's try 441. I think it's 21. So let's try this guy. Now you can apply factorization, that's fine, prime factorization, but what is the quickest way? Range method. Let's try this one. So 4 for 1 will be between these two guys, 400 and 900. It means the square root of this should be between 20 and 30. Correct? Okay. So now look at this table where we have 1 at the unit place. 9 and 1. Okay? So it means I have to just check 21 and 29. Let's multiply 21 by 21 and 29 by 29. So this is 21, 2, 4. So 441. We got it. So this is a perfect square. So what we found, using this range method, we can minimize the range which we have to look into to find whether this number is perfect square or not. And inside that range, look at this table, because you don't have to multiply 21 by 21, 22 by 22, 23 by 23, up to 29 times 29. Because 1 is only for 9 and 1. So 1 is at the unit place only if you have 29 or 21. So basically you have two numbers to check. And you check 21 times 21, you got 441. Okay, now you know it's a perfect square. So using this method, you can quickly find whether a given number is a perfect square or not. To get it? So let's recap. So if you are asked like quickly, you are given a number and you are supposed to find whether it's a perfect square or not. So first thing you have to look at, okay, what is the digit at the unit place of that number? If it's one of these 0, 1, 4, 5, 6, 9, then that number can be a perfect square or cannot be a perfect square. But if it has 3, 2, 7, 8, it means it's not a perfect square. So looking at the number, look at the digit at the unit place, and if one of these guys, you can directly say, okay, it's not a perfect square. And if one of these guys are there at the unit place, then you have to apply either prime factorization or this range method. So prime factorization, if the given number is small, you can try this one, which I already explained. But if you have big number, in that case, I recommend use this range method, because applying this range method, you can find the range for the square root of the given number. And within this range, you don't have to check all the numbers, not all like how many, 1, 2, 3, 8, not all 8 numbers between that given range. You have to check sometimes maybe just 1, or most of the times is 2. So you have to just check 2 numbers and you will come to know that whether the given number is a perfect square or not. So it's very handy way, like you can solve the question within a minute or two. But if you are applying this factorization, yeah, it will take, you can solve, but it might take time if the given number is a big number, like 4-digit or 5-digit number. So here you can see it's like already 5-digit number here. And if you go ahead like 200 and like 20 up to 20, so you can get like 4, 1, 2, 3, 4. So it's a big number, and you can memorize the square of like up to 30 in that way. Like you have 9, 1, 2, 3, 4. So very big number. So this way, up to 90K, you can solve the question within a minute or two. I hope you understood. Okay? Got it? Okay.